Okay, so here we have our problems set up again. I lined them up vertically this time so you can kind of see how we're going to use this elimination to solve these two systems, or this system of two equations here. So we talked about on the last slide how equal and opposite means that we have to find the same coefficient, 2, and opposite, positive, negative, with the same variable behind it. So we have equal and opposite variables here. So what those do is they cancel each other out, because it's like we have a negative 2y plus 2y. So basically we're adding these two equations together. So I'm going to change my color here. Okay, so when we add these two equations together, we have 5x, and then we have a positive 1x. So we end up with 5x plus x, which gives me 6x. The negative 2y and the positive 2y cancel each other out, and we get equals, and then we have positive 4 plus 8, which gives us positive 12. And now it's a single step equation that we solve for x. To get x by itself in this equation, we divide by 6 on both sides, and I end up with x equals 2. Now we go to that last step, which is to plug back in and solve for the opposite variable. So we're going to use one of the original two equations, it doesn't matter which one, and we're going to plug x back in. So I'm going to use this second one here. So instead of x, I put 2 plus 2y equals 8, and now I solve for y. So I'm going to subtract 2 from both sides, and we get 2y equals 8 minus 2, which is 6. And then to get y by itself, we divide by 2 on both sides. So I end up with y equals 6 divided by 2, which is 3. And now for my final answer, I'm going to get 2, 3. And that's what we would type into our answer box. Okay? So I'm going to go through another example on the next slide.